award ceremony, and other related activities.
Distinguished leaders, honorable judges, students, and dear friends online, good morning. Welcome to the live broadcasting innovation competition of Huawei ICT competition 2021 to 2022 global finals. I'm Bella, very honored to be here with you to witness this moment, and thank you so much for your coming. This year, the innovation competition is again held online. Despite the long distance, the students' enthusiasm for technology and their belief in using technology to change our lives and future remain unshaken. So we gather here again for an excellent ICT innovation competition. If you are an old friend of the Huawei ICT competition, you will recall it is a stage for global university students to compete and communication. The competition consists of the practice competition, industry competition, and innovation competition. The innovation competition focuses on the application of emerging technology such as IoT, big data, and artificial intelligence. The keys to winning are the ability to innovate, entrepreneurship, teamwork, and collaborative development. So contestants should have solid ICT skills and accurate awareness of the ICT development trends, deep understanding of the industry, and creativity in using technology, so that they can design and create the excellent and creative pieces of work. After multiple rounds of the competition, 22 teams from the UK, Brazil, Kenya, Ghana, Singapore, Malaysia, China, and other countries and regions have made it to the global finals. So today's competition will last one day and have two sessions. The morning session will start at 9 a.m. to 12, and the afternoon session will be started at 2 p.m. and to 6 p.m. in Beijing time. So to our audience online, please stay tuned. The contestants will appreciate your support. So today we have so many guests and leaders and our honorable judges to come here. So now please allow me to introduce them. They are Mr. Jing Xuefeng, scientist of Huawei AI-based software and director of the Central Software Architecture and Design Management Department. Welcome, Jing Xuefeng. Welcome. And our Mr. Sun Gang, Director of the Talent and Ecosystem Development Department of Huawei Enterprise BG. Welcome. Of course, we have our 5 outstanding judges right here now. We also introduce them. They are Professor He Qingming, School of Computer Science and Technology, Zhejiang University. Welcome. Professor Xinlei Hua, School of Computer Science, Huazhong University of Science and Technology. Welcome. Professor Zhu Ming, School of Computer Science, Sichuan University. Welcome. And Li Hongqian, Director of the Huawei Harmony OS Talent and Ecosystem. Welcome. Okay, and Chen Zhongming, Huawei Mindsport Architect. Welcome. Okay, once again, let's give the warmest applause to our leaders and judges for attending today's ceremony. Welcome. And now we would like to invite Mr. Jing Xuefeng, scientist of Huawei AI-based software and director of the Central Software Architecture and Design Management Department, to come on the stage and deliver the speech. Let's welcome.
尊敬的各位评委，各位参赛选手以及
Dear
在线
contestants
参加观看
and those of you who are joining us online, good morning, good afternoon, and good evening.
华为中央软件院的
I'm Jing Xuefeng from Huawei Central Software Institute.
华为的 AI 框架。
I'm now responsible for the architectural design of Mindsport, an open source AI framework. I'm very glad to be here for the Huawei ICT competition global final innovation competition. First of all, Please allow me to express my sincere gratitude to the judges for joining us, and congratulations to the contestants who have made it to the global final. The Huawei ICT competition is open to college students around the world. It aims to provide an international platform where students can learn from each other, expand ICT knowledge, and enhance hands-on practical skills and the ability to use new technologies and platforms to make innovations. The innovation competition, as one important track, focuses on emerging technologies such as artificial intelligence, mobile operating systems, IoT, and big data. It evaluates contestants' ability to work in a team to make innovations. Contestants, therefore, must have solid ICT skills and innovative thinking. They should also be able to work with others so that they can turn knowledge into innovation, which then becomes a product. This year's innovation track, despite the pandemic, has attracted over 400 teams from universities and colleges worldwide. 22 of them have made it to the global final. I look forward to outstanding entries in the final. More importantly, I hope they will turn into real-world applications. For example, the team from Shanghai Jiao Tong University won the first prize of the innovation track in the fourth year of the ICT competition. Later, they got funding, set up their own business, refined the product, and brought it to market so that technologies can truly contribute to society. In addition, I hope contestants pay more attention to Huawei ICT used in the competition. Huawei is becoming an ecosystem enterprise. We have developed the MindSpool AI framework for all scenarios, Open Euler, Open Gauss, and Harmony OS, a distributed mobile OS. I see many projects are based on MindSpool and Harmony OS, but they have only been around for a short period of time, so there is room for improvement. So I really hope that you can give us feedback for us to optimize them. Last but not least, I wish every contestant great success in the global final.
Thank you. Thank you so
Thank
much.
you.
And please be seated and listen and witness our competitors' wonderful performance. Thank you again. So now let's continue. The order of the team has been drawn during the opening ceremony of the Huawei ICT competition grand finals. The details are as follows. Let's check on the screen. You can see we have like two teams from the Latin American and a team from our China will be in the morning session, which is 1 to 10. 1 to 10 will be the morning session, will be performance in the morning session. And other 12 teams will be the afternoon sessions. So now our students and our guests online, you may take a screenshot or take a picture, then you can remember all the details in your turn, okay? Give you seconds. Yeah, the morning session is 9 a.m. to 12 a.m. in Beijing time. And the afternoon session is 2 p.m. to 6 p.m. in afternoons. Okay, let's continue. So before we begin the competition, I will explain the judging rules. So first, After a contestant presentation, the 5 judges will score the team. The judges will find the scorecards on your desk. A full score is 100 points. The team will be the comprehensive evaluated from the 5 dimensions of innovation, system complexity, commercial value, functional completeness, and presentation performance. Each dimension will be scored as follows. Let's change. Yeah. Right here is judging rules. You can check. I'll give you the details. The innovation is 30 points. The dimension evaluates whether the team solution can solve the problems in real industry situation with no existing solutions. It also looks at whether the team has made breakthroughs and innovation in business models, management operations, process optimizations, and application scenarios. The second one is system complexity. This one is 25 points. This checks whether the team effectively uses resources and platform provided by Huawei and whether the team integrates possible ICT technologies to add more value to their solutions. Then it's commercial value. This one is 15 points. The exams whether the team solutions has potential for commercial profits or public welfare. The fourth one is functional completeness. This one is 15 points. This looks at whether the solution takes into account all aspects of the problem and provides complete functional implementation for all possible issues. The next one is presentation performance. This one is 15 points. This assesses whether the speakers and the respondents of the team can fluently explain their work, clearly answer the judge's question, and present the concrete views. So we look forward to your wonderful performance. So the judges will score the competing teams using these 5 evaluation dimensions. The special prize and the first, second, and the third prizes of the innovation competition will be awarded to the teams based on the final scores. The results will be announced and awards presented at the closing ceremony of the 2021 to 2022 Huawei ICT Competition Global Finals on June 25. So please stay tuned. So each team will have 15 minutes. They will have 10 minutes to explain their design ideas and present the solutions, and 5 minutes to answer questions from the judges. To ensure a fair competition, we will set a 1-minute countdown bell for the presentation. So during doing your performance, so 1 minute left, we will listen a doorbell ring. So that time you can still continue, but you only have 1 minute left. Right. So please manage your time wisely. We will move on to the next team when the time is up. The stage now is ready for our contestants. Let's welcome the first team from Universidade Federal do Ceará in Brazil. So, yeah, let's wait a little bit. Yeah, we once again explain. First, you have 10 minutes for performance. Then, the time's up will end, and the next is the judge's question, and you will be the answer the questions. Let's wait the first competitor. Yeah. So and this one, and now we mention others teams. Please, yeah. If you are the next team, you still stay on the. Please still stay on the our channels and waiting for our the first one finish. Then it's your turn. So now let's wait 1 minute more. I think our competitor is doing the preparation. And then later, when you online, remember to unmute yourself and turn on the camera for your presentation. And also, please correct your channel, language channel, to make sure you're using the correct one. Yeah, the first one is from the Latin America. Let's wait a moment. Yeah, after your performance, our 5 judges will remark the score on their score desk. Yeah, let's wait a little bit. I think there is something connection problem. between. Yeah. So now, just doing more preparation. We have a little bit more time for you. Okay. And remember. Okay. So now the first one is ready. Now we cannot see you. Please connect. Please connect. So, Universidade Federal do Ceará in Brazil, are you online? We cannot hear you now. We cannot hear you now. And please, the team 2, be ready. Okay, I will introduce the 10 team in the morning session. The first one is Federal University of Ceará. The second one is Federal University of the Algas. Then from 3rd to the 10th will be the Chinese team. China University of Geoscience team. The fourth one is Central China Normal University team. And fifth one is Dalian Maritime University team. The sixth one is Beijing Jiaotong University team. And the seventh one is Shanghai Jiaotong University team. And eighth one is South China Normal University team. Then the ninth one is Xiamen University team. And 10th is East China Normal University team. We still not can connect them, right? Okay, let's wait a little bit. Okay, right? So be ready already. Okay, let's see. Please show the first team on the screen, then we can see them. Yeah, the Group 1 University Federal de Ceará team. Okay, so please unmute your voice, right? We cannot hear you. We cannot hear you. Please unmute your voice. Now we can hear you. Now finally we can hear you.
Okay.
Yeah.
Yeah.
But we still
Sorry.
cannot see you. We cannot see you. Check your camera. What's wrong with it? Can you check the camera, or we cannot see you right now? We can hear you now.
Yeah, my camera
Oh
is
yeah, now
activated right
finally I can see you right now.
Hello.
Okay. Okay, please unmute yourself and turn on the camera for your presentation. Your presentation, your work.
Okay. Just a second.
Okay.
Uh,
So this is give a good example for other teams later. Please be ready for this. Okay. Yeah, now we can see. I think now we can see. Okay, you have 10 minutes to present and 5 minutes to answer the questions. So that's a total of 15 minutes. Now we cannot see you again. Now we cannot see you again. So we need more like competitor bring us the solutions like this in the future. Yeah, so other teams, if you are online, please mention this and please realize this. You need to turn on your video. I cannot see you. I cannot see you now. Okay, now I can see you. Now I can see you, but I cannot see your work. Oh, okay, finally.
right.
Yeah, right
okay,
now.
that's fine.
Yeah, yeah. Then you
Okay.
have 10 minutes for performance. Please manage your time wisely, okay? Now 10 minutes start.
Okay, thank you.
Oh, it's your turn now.
Okay. Hello, everyone. Good evening and good morning. My name is Igor Linhares from Federal University of Ceará, Brazil. And I'm going to present our project named Smart Health UFC, Identifying Health Risk with Wearables and Cameras. Our team is composed by me, Raissa Ellen, and our professor, Maciel Barros, and we're representing Federal University of Ceará, Brazil. First, I'm going to talk about new concepts of Health 5.0. After that, I will explain some important trends in health. Therefore, I will show how these friend helped us to propose a solution for a well-known health problem. And finally, I will present the Huawei technologies we used when developing this solution. First, let me talk about Health 5.0. This concept combines both consolidated and emerging technologies in health applications, such as 5G, blockchain, IoT, big data, artificial intelligence, cloud computing, and so on. In recent years, health service providers they have changed their focus considering upcoming health applications with technologies. They are asking how they can fit in their customers' lives, thus how to make people access health applications in a simple way. Also, they concern about which technologies they should use to develop these new solutions. Here we talk about the new applications. Here we talk about new applications required by the users themselves. According to this report, there are some important trends in Health 5.0. Let's notice that there are some trends which relates very well in IT scenario, such as the concerns about privacy and security, the telemedicine for remote care, especially after recent pandemics, the employ of artificial intelligence in healthcare, and the use of IoT and wearables to monitor users in health scenario. Also, according to a recent report of New York health business leaders, there was a growth of more than 150% in funding for startups that produce new applications in digital health. Regarding this growth, the virtual care and coordination has received the largest amount of funding. So, it is important to concentrate efforts on the development of upcoming health applications in this scenario. But let us define a risk, right? If a person is subject to any behavior that may lead to severe injury or death, we say the person is in risk. Considering this, one of the main risk events in health are falls, which are the second leading cause of those unintentional injuries and also death, especially for elderly people. According to statistics, 5% of elders require medical attention each year because fall injuries. Um, Considering this, we propose the development of a secure system for remote monitoring of people under these conditions. We consider a mobile architecture to identify health risk events using artificial intelligence with collected data from wearables and cameras. This picture shows a high-level concept of our proposal. The people can be monitored by using a wearable device. Uh, if a person if a person is in a room, we can also employ cameras to identify which activities are performed by the user in order to detect risk events. Uh, all this information will be transferred to cloud servers, and these servers will be responsible to handle and process wearable and camera data using artificial intelligence. If the result is a risk event, a notification is sent to a health provider or to the family. By this point, some resources are needed, and there are many Huawei solutions we can employ to this application. Such as for data acquisition, we suggest the use of Huawei Watch GT sensors to collect movement information and Huawei dumb camera for video streams. Also, the management of these IoT devices can be done in a Huawei mobile application, which will be shared in an app gallery, executing in a Huawei Mate Mobile, for instance. To execute our solution in Huawei Cloud, we need an ECS instance for MQTT, authentication services, databases, and file services to store new data to help the improvement of our models. Finally, we combine artificial intelligence provided by Huawei Model Arts. Uh, yeah. Our proposed solution is also compatible with Huawei Atlas Ascend, considering edge nodes to execute machine learning algorithms. Uh, Finally, we present in this picture a combination of Huawei technologies in our project. Let me talk more details about each approach, both wearable and camera. This slide presents a wearable-based solution. We propose data collection from a Huawei smartwatch. and the data is sent to a mobile phone application which sends data to a cloud server. In Huawei Cloud, some machine learning algorithms execute a prediction for the incoming data, and if a risk is detected, a risk message is sent to another mobile application of caregivers or family members. On the other side, we have the camera solution, which is based on a video stream sent from a Huawei DAM camera to an endpoint in Huawei Cloud ECS by the RTMP protocol. The server executes a computer vision plus machine learning application to find human bodies skeletons from images and predicts possible falls based on these skeletons, as shown in the slide. And finally, a mobile application receives a notification indicating a risk of user based on camera data. It is the same application as the wearable, so a user can receive risk detection from the wearable or from the camera. Basically, it's this. Thank you very much for your attention, and now I'll be open for questions.
So you already finished your performance?
Yeah.
Okay, thank you. Okay, so now it's for the judges' questions. 他的这个演讲完毕。Now it's for your turn, and our judges, you have 5 minutes for the questions and answers. You know that. Okay. 我们有5分钟的时间。那么接下来，请我们的评委来开始进行提问，有请。Okay, you can take your 你可以拿着麦克风。Okay.
I have a question. I'm wondering, do you have a specific device or scenario for this solution, or is this just a concept? This is my first question.
Can you hear our translator? First of all, can you hear our translators? You can hear, right? Can you hear the questions?
Yeah.
Okay. You now you know the first questions, right? Already, right?
Yeah.
Okay. 可以继续。
So I'm just wondering if you have a specific application or situation. The second question is, you say you are using Huawei Dome camera. So, for the elderly, the most dangerous situation is when they are in the bathtub, when they are in the shower. But it's not very appropriate to install a dome camera in the bath. Do you think so?
I'm sorry.
The second question is like, you said using the camera, but if the old lady or older man in the shower, if you using the camera, I think it's not very correct way. This is the second question. Now your 2 questions already.
Yeah, we have these privacy concerns, which is obvious that we would not use the camera inside a bathroom. But for that, we can use the wearable solution. So the person can use the smartwatch anywhere the person goes. So that would be a solution for this. And did you do 2 questions? Did you make 2 questions?
Yeah, the first question said that do you already have the devices exist or just an idea right now?
Yeah, no, we already have all the devices. We did deploy some prototypes. So we constructed all the architecture to support this application. We have some prototypes of mobile applications, and we also tested our solution in health environment. We applied it in a hospital right here, which is the hematology and hemotherapy center from our stage, which is called EMOSI. We tested for around 2 months there, and we had a nice feedback from them from the solution.
Okay. Now you can turn off your work, and then you can turn on the camera. Then you can see. Yeah. Okay. Now it's better.
Thank you.
继续。有请。Okay.
I have a question. When you use wearables to detect and prevent falls, what metrics do you detect? Can you give us some examples?
Can you hear?
What metrics or what indicators do you detect in the elderly when you prevent falls?
Yeah, I'm listening.
Oh, so which mean 穿戴指标. One more time.
穿戴设备去防跌倒的时候。
When you use wearables to prevent the falls of the elderly, what indicators or metrics do you measure?
Do you think it's work when you're using your devices to check the people who is falling down? When which is like a percentage? Which percentage or what type of what aspect you can check when it's falling down?
You mean the rate of hits from our solution?
Yeah.
Well, we use some machine learning models. So in our testing environment, we had some great results, such as 96% of accuracy with some machine learning models. And after we applied the solution in real world, let's say that, we also performed some tests. So we had some volunteers that would perform the falls, and we would assure that the falls would be really detected. So we achieved around 80%.
Yeah, sorry, the time is up. Okay. Thank you for your answer. Yeah, you're the first one, you know. It's always difficult to be the first one, but thank you for your performance. Thank you. Okay, thank you.
Thank you very much.
Thank you. Now it's turn to the Universidad Federal de Algos team. This is team 2. Yeah, you're online. So please, let me see you. Please unmute your voice and please show you on the screen. I cannot. Oh, now I can see you. Yeah.
Let me share my screen here.
Yeah,
Hi.
and please unmute yourself and turn the camera for your presentation.
Sorry?
Your work. Let's show your work to us. Now I only can
I'm
see you right
here.
now. Yeah.
Can you see it?
Yeah, I think it's work. So now you have 10 minutes to present and 5 minutes to answer the question. That's a total of 15 minutes. Are you ready?
Okay.
Okay, now 10 minutes start.
Hello, everyone. Good morning. We are Red Flag from FAO. I'm here. My name is Lucas. I'm here with John and Gabriel and our instructor, Rodrigo. And our solution is called Client Mapping using Facial Recognition. So we'll first go over the solution overview. Then we'll talk about the applications to marketing and security. Then go over the solution architecture, and finally go over the solution infrastructure. So due to the increasing demand on physical retail purchases by customers as restrictions from COVID get lifted, market teams saw the need of better tools to track and analyze customer needs, bringing more accurate recommendation to them based on behavior, sex, or age. Moreover, reduced security staff requires a more intelligent solution to identify and track suspicious people, such as our demo here on the right. So this is one of the features of our solution. It's called the customer enters flow, and it can count how many people enter an environment. It can also count how many people leave an environment, and such we can also know how many people are in the environment. And we can also track people, uniquely identifying them, and we can also track their movements as it's shown here on the demo. The other feature is called the heat map, and we can show customer clusters with it. So in areas where we see green, there are less customers grouped, and where there is like red, there are more people in that area. So the market team, for example, can use this map to identify where people are clustered and make use of this information for different marketing purposes, such as placing kiosks or stands in a shopping mall, for example. One of the other features is sex and age identification. We can identify if a person is female, male, or undefined. We can also guess their age based on facial features. The solution is not perfect yet. We are working on that to improve more and more, but nowadays we have the following issues detected. We cannot accurately identify a person due to the use of face masks, and we also can't identify children's age accurately. And so here's our solutions dashboard, where we show an airport use case. So it shows how many people are on the airport right now, right here. We also have a chart displaying how many people visit the airport today by hour of day. Here we have the peak hours graph, which shows which hours register the largest customer flow. We also have a age range histogram separated by gender, which can help the marketing target their sales more effectively. We also have the entrance door flows, showing the percent of people that entered from a specific door in the environment. There is also the monthly visit by variation, which shows the relative flow compared to other months. And we also have this, which is the visitors by month chart, which shows how many visitors we had for each day of the month. Last one is the heat map, which showed before. And so, in summary, the solutions brought to marketing and security. For marketing, we provide customer flow by interest and time. We can also provide kiosk or stand placement using the heat map. They can also better target sales by sex, age, time of day, as shown on the dashboard. And we can also give better customer profiling on the stores. And we also have security solutions, which is identifying and tracking suspicious people, which can help security staff perform their duties. So here is our solution architecture. So let's go over it. So we have the CCTV cameras from the environment. Those go to the DVRs, and those streams go to our RTSP clients. So these RTSP clients are important because we can set the interval at which images are captured by these clients. And this interval can be set based on the available system resources and how much budget is available for cloud services. So depending on the configuration of these clients, we can submit frames to different queues, which in turn get submitted to different providers. So our first provider here is the face recognition provider. It basically submits a frame to the Huawei Cloud High AI face recognition API. We also have our people detection provider, which is a model that was trained and is deployed on the Huawei Model Arts. And finally, we have the face detection provider, which is a locally implemented model to filter faces based on image quality before sending to the face recognition API. And with that, we can save resources by not sending every frame to the API. Finally, we have the people tracking services. In different from the RTSP clients, it receives the raw RTSP string, so the full frames, because it's better for tracking people entering and leaving the environment. So it's deployed on the local environment. It's also really important to notice that our solution is really scalable. So we can increase the number of RTSP clients as we need, and also we can increase the number of providers. So here we show one provider of each, but we can have multiple of them if the deployment needs that. Okay, so here we are talking about some motivations for the for the use of Huawei Cloud services. So people detection and recognition models need high computational power, since videos must be processed in high speed in order to have good accuracy. And Huawei has computing hardware for both training and inference, which might be useful for our needs. And for services that do not demand real-time processing, it's also possible to deploy the model at the Huawei Cloud, as we show with the people detection provider. It is the proper approach for services like count quantity estimation and face recognition. And Huawei offers solutions to support both the developing and deploying of artificial intelligence models through the Model Arts framework. And through Model Arts, one is able to train, manage, and deploy different models And in respect to the deployment step, we can also use different approaches such as EXEML or Reg for use framework templates or even customized containers. So here are the CCTV settings for the cameras. We can use these settings to limit how many video sources we input into the different providers that we've shown before. For example, we may not need the people counter to be enabled on cameras other than the ones that are present on the entrances for the environment. Here we have the face recognition page, and this page uses the results provided by the Huawei face recognition API and displays the person that was identified by a specific camera. And this can help security staff quickly finding a person on the environment. This could help in the case of a lost child, for example. Finally, we have our system infrastructure. So we went with the AdStation Atlas 500 AI, which has real-time data processing. It can process up to 16 channels of HD video. It also has Wi-Fi and cellular module and can withstand harsh weather conditions, which is ideal for our deployment. But that's it. Thanks.
Thanks. Thank you for your wonderful performance. So now is 5 minutes, judges' question and your answers. So, and please turn, yeah, you already turned off your camera. Okay, so now 5 minutes. Are you ready? Okay, start. 那么接下来有请我们的评委老师。
Hello. So when you do facial recognition, have you ever considered the issue, for example, the same person, when they appear in front of different cameras, you may have duplicate identification, even if there.
Yeah. Actually, about this face recognition, we thought about problems with submitting too many frames to the Huawei identification service, like the face recognition API. And so we use that, which I showed before, our local model to detect faces and only submit those that are good enough to be detected. And so that's what we did about those problems of sending duplicates. It also has a filter, a local filter.
Okay.
So in terms of privacy protection and data protection, have you ever made any design to protect privacy and security?
Yeah, so these are deployed locally on the environment. So it's mostly based on physical security, right? And since it's Docker containers, we can also put a security layer around them if we need for that deployment.
So speaking of people tracking, do you use the facial images or the motions to track the people?
Yeah, we use the faces of the people to track them.
Okay, one more question. In terms of performance, could you tell us more about that? For example, how many people can you track simultaneously? For example, in a very big mall, how many people can you track?
Sure. So the solution is really scalable. So depending on the number of people, how big is the environment, we can deploy more providers and more clients, more RTSP clients to get more video streams. And it really depends on the budget that the client has available for the system. We can we can deploy multiple providers. And talking about the people tracking, since it's local, it really depends on the video card available on the client infrastructure. That's it.
So I mean, the maximum number of people can you track with your device?
Yeah, with our current solution that we tested, we couldn't track basically all the entrances of a shopping mall, right? We didn't have access to the internal cameras, only for the entrance cameras, but that's what we actually tested with the infrastructure we had there, because we did not have access to Huawei infrastructure, only their servers there. So basically a shopping mall.
Okay, that's all. That's all. Thank you for your answer. Thank you. Thank you.
Thanks.
Yeah, let's wait the
Bye.
finals. Thank you. Yeah, now we continue. 那么接下来呢，我们就进行到的是将由
Now let's move on to the third team. The next third to the 10th teams will be from China.
If you're online, please check your bottom of the screen. There is a button. You can change the language. There is English channel and the Chinese channel. Yeah, in the bottom of the screen, you can check. So now it's like 8 teams from the China. So we would like to invite our third team. 中国地质大学来自武汉中国地质大学的
Now we will have with us the third team from China University of Geosciences. Please turn on your camera and unmute yourself. Can everyone see me?
好的，稍等。那我现在可以看到你了。
Yes, please wait a
将
bit.
你的这个文件共享到公屏上。
Please share your screen.
可以听到声音吗？
是可以的。
Can you hear me all right? Yes.
谢谢。OK，可以看到屏幕了。
Can you see the screen now? Yes.
您将有这个10分钟的作品陈述
You have 10 minutes for presentation and 5 minutes to answer questions. A total of 15 minutes.
好了，准备好了，谢谢。
Are you ready? Yes.
倒计时开始。
You can get started.
好，各位评委老师，大家好。
Hello to all judges.
中国地质大学
We're from the China University of Geosciences.
带来的项目是
Our team is called the Future City Team. The subject of my talk is Distributed Rapid Object Detection System for Large-Scale Remote Sensing Images. My talk will cover 4 parts. First, introduction to the project. Here's the background. You know, remote sensing images contain a lot of information. They are widely used in land planning, fishing, traffic detection, military reconnaissance. And a lot of images have to be processed to gain effective information. We come up with this project to provide easy-to-use, convenient, highly scalable systems to detect objects in remote sensing images so that we can analyze a lot of land objects such as airplanes and ships. Here are the project difficulties. First, application cost is high. There's a lot of remote sensing image. They're usually at TB or PB levels. We have to process a high volume of data, and data processing takes a lot of time. And data processing relies heavily on expensive GPU resources. The second difficulty is inference is quite slow. Another thing is, compared with images in natural settings, it's more difficult to detect objects in remote sensing images because they have different orientations and sizes. Here are the different modules of our project. We do massive data management, flexible model switchover, distributed inference. They are embedded into 3 modules. We can do distributed data management at the back end, and we can analyze and get the inference result. Now I will show you the technical solution. It includes 2 parts. First, how we optimize the object detection model. Second, the distributed inference framework. We use the DOTA dataset. Here's a comparison between DOTA and other object detection datasets in aerial images. We use rotated bounding boxes, and 18 categories of objects are supported. There are about 1 million objects and 10,000 images in this dataset. Here's how we optimize the model. This is the architecture of our solution. We use the YOLO V5 model and further refine it. Here are the functions we use. We introduce the CSL module and the rotated bounding boxes for object detection. We also use a weighted solution to further improve the precision of the model. This increases the model detection accuracy and will not affect the inference speed. In this way, we have a real-time detection model that can support large-scale remote sensing images. Here's a comparison between our model and existing ones on the market. Our model has the highest precision and the inference speed. This is the distributed inference framework. Here's how it works. We deploy the model on Huawei's Model Arts, and we introduce object storage OBS, cloud hard disk EVS to complete the system. The backend gets data uploaded by users. From the front end, the user can select the inference models. It can be distributed or standalone machine inference, but the detection results are the same. And users don't have to pay attention to how the solution is implemented at the backend. We have used over 5,000 remote sensing images. You can see the speed-up ratio has grown as the number of nodes increases. As the volume of data increases, the performance of our model also improves. Here's the total time for different numbers of nodes. For the traditional single CPU, it takes 5,000 seconds. But when we use our distributed model, we take only 500 seconds. We have deployed the model in the real world. We have taken a screenshot from the Baidu map. It's a square or pedestrian street in Wuhan. It covers an area of 13 square kilometers. We do the inference based on a single CPU and a cluster. For the single CPU, it takes over 2,000 seconds. That is more than half an hour. But when we use our 8-node solution, it takes only 268 seconds. Our inference speed is 10 times higher than the previous solution. Here's a demo. Our project supports the flexible switchover between different models, including remote sensing image detection and ordinary image detection. Our system can also select the categories of objects. By default, there are 6 categories, including airplanes. You can select only airplanes or baseball fields for object detection. Here are the results. You can see the number of images detected and the processing time. And on the right-hand side is the number of objects in each category. Here's the analysis of the inference result. The result will be displayed to users. We can see the percentage of each object in land area. Large vehicles occupy the lion's share of the land. And confidence is about 0.8. This dashboard shows the results to users and helps them analyze the results. This can be used in urban land planning and military reconnaissance. Here we show the number of nodes, the total number of cores of CPUs, and the cluster memory. Here you can see the percentage of each node, as well as the distribution of the objects. Here's the value of our project. I will talk about the innovation in this project and its real-world application. We have implemented the most accurate one-stage algorithm, and it's more accurate than any other detector. This has great significance for object detection of remote sensing images. We have deployed the distributed Spark cluster and HDFS file system. We use relatively cheap CPU clusters to implement distributed inference frameworks for large-scale remote sensing images. The actual inference speed-up ratio is much higher than the theoretical linear speed-up ratio. We lower the hardware costs while improving the accuracy and the speed of inference. Our inference framework applies to GPU clusters and Huawei Ascend computing. It supports Minuspool and PyTorch. Here's the project value in the real world. It can be used in urban land planning, maritime affairs, fishing, traffic detection, etc. And it supports multiple scenarios. It can be used for image or video detection. And we can switch between different inference models. We use cheap CPU clusters to replace the expensive GPU clusters, lowering the hardware costs significantly. We also provide easy-to-use APIs. Users can jump between different models. And this model can be used by both professionals and ordinary people. This is our system. You can see the different modules, including object detection for remote sensing images. Here I will select some images, upload them. Then I click Detect. Take a look at the results. It takes only 337 milliseconds, and 11 images are detected. You can click Next Image to get the result. Let's see the result analysis. You can see the percentage of land area covered by each category of objects.
Sorry.
Your time is up. But you have given a very good presentation. Now let's come to the Q&A. You have 5 minutes. Based on my understanding, remote sensing images are large, and you have reduced the size of them based on your demo. So how do you handle the false negatives? For example, you may miss some objects, or you may make mistakes in object detection. Well, users can decide how to resize the images or what size of the images they want. And there will be overlap. And then we will combine the different labels. There will be overlap between different detection bounding boxes. Based on the overlap, we will set a threshold. For example, if the IOU is 0.1 or is greater than 0.1, we will filter out the results. It shows that there's too much overlap and it's all pointing to the same object. This way, we will prevent duplicated detection. You can stop sharing your screen so that you can see the venue. You use standardized data sets in your detection, but in the real world, the remote sensing images will be affected by fog or rain. Have you ever done an experiment for real-world images? Yes, we have. I just didn't get time to show you. Now let me show you the results of real-world images. This is an image where there's a lot of fog and cloud. You can see the cloud. This is the original image, and later I will show you the detection results. Here are the results. I have one question. You mainly detect objects in remote sensing images. How many categories of objects are supported? 16 in total, including airplanes, ships, and more. Including static and mobile objects. We can expand the category. You can switch to other models to detect new object categories. We also have models to detect pedestrians. So this project can be expanded. The solution has to be used in the real world, such as urban land planning. So have you carried out experiments? For example, if a house is torn down and rebuilt, can you detect the changes in different images? Well, our solution cannot support change detection in various images. We can only count the number of land objects. Now we have counted the number of vehicles in an area close to a shopping mall in Wuhan, covering an area of 13 square kilometers. If we switch to another model, we may be able to support change detection. That's all for the Q&A. Thank you for your presentation. Now the judges will score the third team. Thank you.
Now let's welcome the next team from Central China Normal University. So everyone, please turn on your camera and unmute yourselves. You see me? Yes. Now please share your screen. Can you see my screen? Yes. Okay, now you will have 10 minutes for presentation and 5 minutes for Q&A. And 15 minutes in total. Are you ready? Yes. Okay, now let's start the countdown. Distinguished judges, I'm Xinbi Qiao from the Central China Normal University. So the name of our work is User Emotion Profile Generation System based on Huawei AI framework. My presentation will cover 5 parts. First, introduction. Depression has become a really serious issue for the public, and there is widespread emotion crisis. As internet becomes more popular among people, social media has become a major channel where people express their feelings. And in some cyberspace, there is a lot of negative feelings or emotions. In China, we call that tree holes. So our team's aim is to explore what's inside the tree hole and use deep learning to develop models to profile users' emotions and assess their mental well-being. We collect massive amounts of data and do analysis. We deployed the crisis intervention model and used natural language processing technology to identify users' emotions. and analyze their mental well-being. Then we generate a profile of users' emotions and provide a report. The Huawei AI development platform has optimized the deep learning model development and has greatly improved efficiency. We have mainly used the multiple deep learning model, OpenGOS database, Model Arts, and Huawei Cloud Server. Now, let me elaborate on the project. So the project mainly consists of three parts. First, cross-platform data importing. Second, user profiling. And third, emotion log. First, in terms of data import, we use Python crawler technology to collect data on social media, mainly their comments. Then we apply the crisis intervention model and analyze the comments and put different labels on the data with Huawei Model Arts AI, and the data is stored on the OpenGOS database. Then we created 17 labels. For example, some people tend to put wrong tags on themselves, and some tend to self-blame. And here on the right-hand side, you can see all these other tags. This is the UI of the Huawei Model Arts. We put different labels on users' emotions. Then we use the Albert model to create tasks for the comments and put them into different categories. For example, we enter this text, and after coding and classification, we get the result. And it identifies the problem of putting wrong labels on oneself, which means the user is likely to feel disappointed and they tend to be more emotional, and there are often biases. So this is how we train and deploy the model with Model Arts. With inputs of the analysis, we develop this Lingxi application to provide accurate emotion analysis reports and advice. Users can record their emotional well-being on this platform. Then we use this text to analyze one's mental well-being, and then we display the results. Now I'd like to show you a demo. You open the Lingxi application. This is the home page where the user can create posts recording their mental well-being. Then we analyze this text and we generate results. In the customer emotion profiling section, here we can see there is a curve. It indicates the mood swing of the user. Then we made this chart analyzing the text on the user's emotion. And in the end, we provide the advice from the psychological perspective. For example, here we enter the text, "I'm good for nothing for the 21 years." Now we have created the post. Then we click the customer profile section. Here we can see the curve and the emotional course have been updated. And there are also updates in the analysis part, and there is customized advice. That's all about the demo. Now, I'd like to summarize the 3 highlights of our project. First, it is highly effective. We use deep learning model to automate the analysis of users' emotions, which has greatly improved efficiency. Second, it has leveraged knowledge in AI and psychology, and it has made a contribution to the natural language processing technology. And third, it can be translated into an application. We use Huawei Cloud Platform to deploy the service fast. Now, here are the prospects. First, with the deep learning model, we can automatically identify emotional crisis, which means we can take a more proactive approach to provide guidance for people suffering from depression. Second, our project can provide tools for the so-called tree-hole rescue team. Their aim is to help people who are suffering from emotional crisis, so it has created societal benefits. We have also provided a tool for users who can evaluate their mental well-being by themselves and provide customized advice. And last but not least, we hope that our project will be further integrated with Huawei products and provide a valuable use case for the Huawei AI platform. That's all from me. Thank you for listening. Now I'm open to your questions. Okay, thank you for your presentation. Now, any questions from our judges? Hello. So you mentioned you used MindSpore framework, and you also deployed that on the mobile phone. But the mobile phone is connected to the Huawei cloud. Have you ever used MindSpore Lite to do inference on the mobile end? Answer. We use MindSpore, mainly, after we have got the trained model, then we use interfaces to deploy that to the Android app, device. And for MindSpore, I think we still have a lot of things to learn. But in the future, we may think about using the MindSpore Lite framework. Okay, now you may end the screen sharing. Okay, one more question. Just now, I see in your demo, you use the mobile phone. So on the mobile phone, the users enter a text and you create customer profiles. But I don't think it has wide applications, because I think when you want to express your emotions, you don't necessarily put your feelings or log your feelings on the app. They may express their feelings on other social media accounts. So have you ever tried capturing those comments from other social media accounts? Okay, thank you for your question. We are working on that. For example, the Sina blog, Douban, and the NetEase music application. We try to get data from these platforms, and we do analysis of these texts. That way, we can leverage big data analytics. In terms of Lingxi application, it is mainly for individual users. So it mainly relies on self-created posts to do analysis. And as I mentioned, another application of this app is that we hope that it can be used by a community, so they can have large amounts of data inputs to do analysis, to provide guidance. And we are now working on that step by step. Question. So are there any professionals in your team so that they can, for example, put labels on different emotions? Answer, yes. We have professionals from Wuhan University. They give us psychological inputs, for example, how to put labels on the data. And they also give us theoretical backing. Thank you. Question. Maybe this you can consider it as a follow-up question. Speaking of psychological guidance or treatment, if the conclusions on your app are not accurate or professional, they may instead put the wrong label on the user. So I wonder, is it possible, for example, you send your reports to psychological professionals and they can review these reports or take a double check so that the advice may be more professional? Oh, thank you. I think that's very good advice. We know when speaking of psychology, the comments or the results may have a profound impact on users. And we also take that into account. For example, whether there is human touch with the results. This is what we are currently working on. And back to your advice, I think that's very good advice. For example, having psychological professionals take a double check, that's very good. Okay, in the interest of time, I think that's all for your part. And thank you again. Thank you for your wonderful presentation.
The next team is Dalian Maritime University. This is the fifth team. Please unmute yourself and turn on the camera. Hello to all judges. I'm from Dalian Maritime University. Can you turn on your camera? We can't see you yet. Now we can see you. Would you mind speaking up? Your voice is a bit low. You have 10 minutes for presentation and 5 minutes to answer questions. Now you can get started. Hello to all judges. I'm from Dalian Maritime University. Aluminum is an important material in industrial production. It's also an important part of vehicles. In the production and transmission of aluminum, visual inspection is needed. It poses a threat to safety and it's inefficient. So we need to use AI-powered devices on production lines to do AI-powered inspection. That's why we come up with the low-cost solution for defect detection and classification of industrial aluminum. Our solution combines IoT, deep learning, and AI, and we focus on detect defects in aluminum industrial settings. There's no alternative open source solution in the industry. We use Huawei's Mindspool and Model Arts to deploy and train the model. We also use Open Harmony. Huawei's platform provides a variety of elements, and we use SDKs to obtain product data and images. We have also developed a WeChat mini program to send the results. This is a hardware platform that combines pipe, cloud, and device. Here's the detailed description. These are our core algorithms. We not only use Mindspool, we have optimized the convolution layer. We have changed from the ordinary convolution to in-depth convolution. We also use enhancement technologies such as Gaussian blur and color disruption. There's a comparison of results before and after the optimization. You can see the calculation amount is reduced after the optimization, and the accuracy is improved significantly. We have built a conveyor, and we use the screen main control chip and bare pi. When the aluminum block reaches the designated position, the detection starts, and then the algorithm will determine if it has defects and should be placed in a designated area. Data can be uploaded, and we use Huawei OBS to store product information. We have built a .NET website on Huawei's ECS. In this way, this makes inspection more intuitive, and we can better monitor the quality of products. This is the prospect of the project. It comes at a low cost, it's easy to use, it's highly accurate, and has fast detection. We have built our own website and mini program to show the results. The project can be used in industrial settings, for example, aluminum detection for loss. And we have taken into consider various settings so we can meet the needs of real world. Next, we will give you a demo. Hello to all judges. This is what our product looks like. This is an HM Nano. You need to raise your voice. We can't hear you clearly. It's better now. This is Nano. This is a model for inference. This is bare pi. It uploads data from IoT device access. We can't hear you anymore. You need to raise your voice. How about now? It's better. Please proceed. This is the GUI we have compiled. This is the real-time video with which you can check the status of the material. This is a original image captured when the aluminum block gets to a specified position. Here are the results. How many defects have been detected? You can see it right here. Here you can see the image status. It's uploaded successfully. Here are some area thresholds. You can set thresholds to better detect defects in aluminum materials. Let me show you the whole process. This is an aluminum block. I can check out the screen. It reaches a specified area and detection starts. Here I can see the results. There is a defect. Something is missing on the back. Let me show you another block. It has only a small defect. Let's see how the detection works out. You can see the defect type is displayed on the screen. This block has multiple defects. All the defect types are shown here. This one doesn't have any defects. When it gets to the specified area, it continues on the conveyor. That's all for the demo. We also use a mechanical arm, but the CCB is damaged during our experiment. So I'd like to play you a video to show this. If there are defects, the mechanical arm will take the aluminum block to a designated area. That's all for our presentation. Thank you for the demo. You can stop sharing your screen. You have 5 minutes to answer questions. Hello, I have a question. How do you define defects? This is the first question. Second, based on the demo, you take pictures to see if there are any defects. But if there are defects on the back or on the side, will you be able to detect them? I can take the first question about how to define defects. Our data set comes from an algorithm competition. We have modified it and made it what it is. The defects are defined by aluminum manufacturers. Some of the defects are recognized in the industry. If there is paint applied to the material, we need to apply paint to the aluminum. If the paint cannot be applied to it, it's considered a defect. This is a widely recognized defect in the industry. They all agree on the defect. I will answer the second question. We detect based on images. In industrial settings, the aluminum may take other shapes, or they have different orientations. If you want to detect a piece of aluminum in the shape of a circle, then we can put a camera on the side to detect defects on the side. I hope that answers your question. Hello, the detection speed is not very high. There is a pause, and then after a while, the result will come out. Have you thought about rotating the aluminum so that you can take images of each angle? But in that case, the detection time will be even longer, and some defects will be missed. Another thing is, I think the defect result is wrong. It says air bubble, but in reality, you told us the last piece of aluminum has no defects. So how do you explain the error in the detection result? I will answer the first question about the detection speed. We use the mind spool and model inference of that platform. So we use the mind spool LED for inference. The thing is, it's only deployed on Huawei's Atlas. It's not deployed on Linux. And we're using a 64 32-bit Linux. On the official website, there's a 32-bit Linux version. Compilation is not supported. So it takes about 100 milliseconds to compare each frame or to look into each frame. If we don't use MindSpore, we can improve the detection speed. It can be 10 milliseconds, and it can be increased further. But since we're using MindSpore, and the inference framework cannot be deployed on Linux, that hurts the detection speed. Well, MindSpore can be deployed on Linux and Android devices. You can check them out. But according to the official website, only 32-bit versions are supported. Thank you for your answers. That's all for the Q&A. Every contestant only has 5 minutes to answer questions. Thanks again for a wonderful presentation and for answering the questions. Now we have examined 2 teams from Latin America and 3 from China. We'll have a 10-minute break. Next, we will have teams from Beijing Jiao Tong University, Shanghai Jiao Tong University, Xiamen University, East China Normal University, and South China Normal University. We look forward to your performance. We'll see you in 10 minutes.
好的，我们还有1分钟，还有1分钟，开始。好的，欢迎各位评委老师，我们现场的嘉宾以及正在直播间
Welcome
观
back.
看我们的学生们、我们的朋友们，来，欢迎大家继续回到华为 ICT 大赛全
Here
球总
we are
决
back
赛
in the
创
innovation
新赛的
competition
比
of the
赛上，
Huawei
我
ICT
们接
competition
下来的比
2021
赛
to
继续，我们
2022
将
global
首
final.
先有请到的是北京交
Now
通
let's
大
welcome
学的
the
比赛
next
队伍，
team from
来，
Beijing 交
请
通
解除你
University.
的这个静音，
Please
把开
unmute
你的声
yourself
音，让我
and
们
turn
看
on
到
your camera.
来自北京交通大学的同学。来，此
老师您
刻，
好，
哎，可以看到你了，可以看到你了。
Hello
来，此刻
everyone.
请将你的这个我们的这个文件，你的这个自我
Okay,
介绍
now
共享到公屏上。
please
来，
share your screen.
好的，谢谢老师。
好的，你将有10分钟的作品展示时
You
间，
have 10
以
minutes
及
for
5分
presentation
钟
and
的
5
答辩
minutes
时
for
间。
Q&A.
好的，明白了。接下来10分钟倒计时
Now
开
let's
始。
start the countdown.
尊敬的各位评委老师，大
Distinguished
家上午
judges,
好。
good
我们
morning.
是来自北京交通大学的参赛队伍。我
We
们
are
参赛
from
的项
Beijing
目
Jiaotong
是华为
University.
有基于华为
The
IoT
title of
小
our
车的智
work
能
is
分拍系统。
Intelligent Follow Shoot System based
我
on
将从
Huawei
方式
IoT.
的方
We
面
call
来
that
讲述我们
Follow
的作
You.
品。
My presentation will
近年
cover
来，
4
越来越
parts.
多的人选择使用短视
Nowadays,
频
more and more
如报道
people
的方式，
are
记录生
making
活中
short
的生
videos
活点
to
滴。
record
中国
their
国有
life.
网络信息中心的统计数据显示，
According to
短视频用
statistics,
户规模和
short
使用
video
尺寸的
users
逐年拍
have
升。
been scaling up
而目前，
over the
主流的视
years.
频拍摄方式包
One
括多屏幕
mainstream
手持
video
摄
making
像
method
和摄像师
is by
跟
holding
拍，
a self-held
但通过
devices
拍
or
摄的
having
视
a
频拍摄
photographer
效果不好，
making the
而
video.
后者的成本也
But
太
for
高，
the
不
former
适合自
one,
媒体作者。
the angle
因此，
is
我们
not
的视角
diverse
呢，
enough,
要
and
以
for
能
the
够给
second
到
one,
高的
it is
视
not
频质
that
量为主。
friendly for
基于此，
self-media
我们
users.
开发一款
That's
以
why
互联网
we
视频
decide
导
to
向为基
develop
础的
this
智能分拍
product.
系统。这个系统包
We
含
have
一个
developed
自带
a
智能追
smart
踪
follow
和智
shoot
能定向
system.
模型，基于
It
华为
has a
IoT 智
target
能小车
tracking and
和一体
smart
拍摄生
obstacle
态的
avoidance
华为一
models.
体的
It
无码
uses
操
the
作系统
smart
的交互
vehicle
APP。
and a Harmony OS based
下面介绍
application.
系统的实现原理与相关技术。
Now, here
我
are
们
the
选择使用了
technologies.
英伟达 Jetson Nano 开
We
发板
used
作为小车
the
的动力主板，
NVIDIA
和华为红火车开发
NVIDIA
板制造
Just
的
Nano development board,
我
as
们
well
拥有
as the
APP 基于自
Hope
带的
Brown
HarmonyOS， 视频编辑的基
toolkit.
础使用华
We
为自主
used
学
Huawei
习，
Harmony
深
OS
度学习框架使用 Mindspawn。
and Mindspawn deep
在目
learning
标检测模块中，
framework.
我们使用了 Coco 中的 Person 数据集来训练一
For
个丢了网络
target
的小车。
detection, we use
通
the
过了
data
看待关键
sheet
损失，
in
衡
Coco
量预测
to
光和
train
真实
the
时间的
ULO
差异，
5S model.
最后使用
We
分时代执行算法，通过两
calculate
个
the
短时间
IOU
框内最
to
大清晰度的
compare
检测框，来
the
抑制其他的每一
performances.
个候选框，完成检测光的
And
实
then
现。
we have this detection
在目
model,
标追踪模块中，我们
detection
首先
box.
使用 YOLO-VOS 模型
We
检
first
测目标，
use
获得
ULO
可视识别目标，
5S
然后
model
通
to
过
detect
与
the
上
object
或
and
图的
draw
来
an
缩
initial
小我们
box.
的目标追踪能力。
Then we take into
我们使用
account center
Coco 一
loss
体
and
的
coarse
数量级
entropy
的
loss
轻量级的 ResNet
to
网络，
enhance the
通过
target
输入
tracking
实际时
ability.
间的序列，
We
提取目
use
标追踪
Coco
的序
data
列，
sheet
最后
trained
再通过
lightweight
API 的计
ResNet
算
network
对视频组
to
的
train the
进行
model, and then we use NMS
下
to
面来
reduce
介绍我们系
redundancy.
统整个的使用流程。
Now this is
用
a
户可
flow
以通
chart.
过搭载有鸿蒙 OS 移动终端上
The
的
user
手机
can
来
use
控制小车
a
的
Harmony
行
OS
驶。
based application to
小车
control
与人
the
机别
smart
进行
vehicle.
后，用户自
The vehicle can complete video making tasks according to configurations. It supports smart obstacle avoidance, and after the video is made, it will be automatically uploaded to the cloud for storage. And the user can use the application to do some simple editing of the video. This is the UI of the application. So first you need to install the application. Then here are several parts such as routing, target tracking, and smart obstacle avoidance. This is the smart vlog vehicle. It has two highlights. First, it is highly adaptable. Here we have listed the parameters and functions of this vehicle. It also supports high precision target identification tracking algorithm. The accuracy rate is over 95% and the frame is over 25 FPS. Now we plan to further improve our products on two fronts. First, to improve the system platform, and second, we want to work out some shooting templates to provide better experience. It has wide potential applications. It can be used for short video making, and it can also be used for detecting anomalies for high-speed railway, and as well as making a video of the chassis of a vehicle. Now I'd like to show you a demo. First, here we can apply filters. So you have made a photo and then you put it in, import it into the application. Now here you can see the communication between the application and the vehicle is normal, is functioning. Now we click take photos, then we have this picture. The transmission speed is very high. Now we can apply filters to the photo. There are different filters. Here you can see. Now click return. Now this video shows how we use an application to control the vehicle. It supports real-time detection of obstacles. Now we can see the real-time images from the vehicle. And on the application, you have two controllers. So you can use the two controllers to control the direction, the moving direction of the vehicle. Now here we have identified an obstacle. Now a person is detected. You can see the box. And on the right hand side there is an obstacle. Now this video shows how to enable routing with the application. Now we can self-define the routes of the vehicle. For example, here you can see there are 4 options. And on the application side, you can also see the real-time images from the vehicle. Now let's click S-shaped corner or X-shaped curve. Now my teammate will show you the real product. Please switch to the camera of my teammate.
我们可能你要把你的这个公屏上的文件先关掉，现在可以了。
Okay, now we can see you.
现在我们来一个情景代入。小明是某社交平台的一个大博主。
Now, suppose there is a vlogger. Every day, he has to make a lot of videos, but he has run into some trouble because it is very inconvenient with traditional devices. So they use the Huawei IoT vehicles. And here on this UI, you can see the real-time images from the vehicle. Now we enable the automatic tracking and obstacle avoidance feature. As you can see, it follows the target, and if there is an obstacle, it will automatically avoid the obstacle. So this is a display of our target tracking feature. Okay, that's all from us. Thank you so much for listening. Thank you for your wonderful presentation. Now, please end the sharing. Okay, we can see you now. So that's the presentation from Beijing Jiao Tong University. Now let's move on to the next part, the Q&A. Any questions from our judges? Hello? So you said your product can be used for making vlogs. To my understanding, if you want to make a vlog, you can just put a device around your ear and you use drones to make videos. But for your product, the perspective is from the bottom to the top, so it may have risks of privacy invasion. So I wonder whether your product can be used for more scenarios, for example, for inspection, for traffic management. Oh, thank you. That's very useful advice. Now our plan is that, the vehicle, we now use it to make vlogs, and the perspective, yes, it is from the bottom to the top, but we can make adjustments so that it can have a higher perspective. And just now you have proposed many scenarios, for example, detection of obstacles or tracking people in some scenarios. I think that's very good input. And here I also have a suggestion. First, again, I think the height needs to be adjusted. If you really want to put it into use, you need to adjust the height of the shooting angle. And just now you also talked to us about your future plans, for example, some configuration templates. For example, in some scenario, maybe the FOV should be wider and some narrower, so you can work out some templates. So when it comes to a certain scenario, the user can just apply this template, and that is really meaningful. For example, think of a scenario. You dance at home, and at different points you need to adjust the angle, the FOV, and so on. And I think if that can be made available, it will be really valuable. Okay, here I also have a suggestion. For privacy protection, you need to think about that. And your product, you can think about B2B and B2C business. And in different scenarios, there may be different requirements. And all these issues must be solved for your future plan. And just now you mentioned the one-click editing and the filter application. Are these features developed by themselves, or is it possible that you can integrate or aggregate features or functions of other software? Well, speaking of the one-click editing and filter application, the features are developed by ourselves. But if we want to provide better experience to customers, we can also adopt some mature solutions right at hand. Now, you may have heard about Dajiang technology. Their device can support follow shoot, just featuring the face. So if you want to make your product more competitive, I think you need to pay more attention to the agility and accuracy and do some comparisons with your competitors' products. Okay, thank you. Thank you so much. Okay, in the interest of time, I think the rest 30 seconds is not enough to answer a question. Maybe for this round, the judges didn't ask many questions, but they did provide many suggestions. And this project, I think, is pretty trending. So I think you can also take these valuable inputs and make improvements to your product. Thank you again. Thank you again for your presentation.
The next team is from Shanghai Jiao Tong University. Please unmute yourself and turn on the camera so that we can see you.
北京交通大学的同学，在你的这个视频的左下角应该是有一个解除静音、打开视频两个。
At the bottom left, you can click unmute.
我们上海交通大学的，来自上海的交通大学的，来，我现在不能够看到你，你看一下左下角是否有一个解除。
I cannot see you yet.
打开视频，哎，现在可以了啊。
Now I can see you.
好的，那么接下来呢？ 请您把你的这个介绍的视频投放到。
Please share your screen.
好。好的，现在我们可以看到了。
We can see your screen now. You have 10 minutes for presentation and then 5 minutes for questions and answers. If you are ready, you can get started. Hello to all judges. Our solution is Huawei cloud-based virtual image generation system. We will talk about 4 parts, including background. First, what do we mean by virtual humans or digital humans? 3D modeling, emotion recognition, intelligent recommendation, and other technologies can be combined to create digital humans. They can hear, listen, and speak and talk to humans naturally. The difficulty of creating digital humans is further reduced in 2022. They will be applied in the internet, finance, e-commerce, healthcare, and more, providing thoughtful, professional, and personalized services to customers. There will be virtual AI anchors in the media industry. By combining creativity and imagination of the virtual world and interaction of the real world, these applications have the potential to truly make a splash in the media world. By 2020, Generation Z accounts for over 40% of all consumers. But there are some industry pain points that we want to address. Metaverse has become a buzzword in recent years. Virtual humans, as an important element of the metaverse, have attracted lots of attention. Due to the high modeling cost, digital humans are not widely available. Our solution aims to address this pain point by leveraging AI technologies to enable fast and low-cost digital human modeling. We need to build 3D models and move from concrete to visual abstraction. We take a concrete image and extract the features and create a face template. Next, I will talk about our research framework. Our solution is based on generative adversarial networks to generate ACG facial images in batches. After we select our favorite original image, we can turn it into a 3D face model with algorithms, and then upload the face models into Unity or UE engines. This is the general framework. First, we enter noise into the GAN generator to create an original image. And then we will fit the original image to a blank face model or face template. The face template can dynamically transform and evolve to better fit the original face image. And then the 3D face model can be used for live streaming. We also need to do style rendering. First, we collect some models, derive the same topology from the models. Then we will do some spatial mapping to get a parameter-controlled generator. Step 3, we can use the current methods to do 3D rendering. Fourth, we process the images. For example, we can do some image segmentation or detect the key points in the image and narrow the difference between the face image and the face template. This is the flowchart. We constantly transform this face template to better fit the original image. Next, I will talk about our technical solution. The most important part is mapping based on the spatial setting. We need to process the data, and we have come up with optimization target. On the left-hand side, you can see the result of mapping. The first image is the original model. The second one is the fitted model. The last one is the facial expression. So the face image can match the blank face template and can exhibit various facial expressions. We have designed a range of loss functions to optimize the model. I will not go into the detail. We use relatively novel methods. We have compared them with traditional ones. We expand on traditional methods. In addition, our methods are compatible with traditional ones. This is the rendering process. You can see the modules highlighted in the red box in this flowchart. We need to further process images to make sure the face image fits the face template. There are two parts. First, we detect key parts in the face, or key points, and we compare them to the template. The second step is to do face segmentation. There may be a lot of noise in the image. We need to remove it and segment the image. Render it. In this way, we can compare the differences between the two images at the pixel level. So we need to take care of two things. First, detecting key points. Second, handling at the pixel level. We detect the key points on the face image, reducing the differences between the template and the image. And get the result. We also need to make sure the result is reasonable. The face should not be deformed, so we add some other constraints. These are the 3 points about comparing different images and figuring out their differences. This is a demo. Here's the result. On the left-hand side is the original face image. On the right-hand side is the digital human we have generated. The digital humans have existing facial expressions and can be used directly. There's no need for extra processing. Last but not least, I'd like to introduce the team members. And here are the members, and on the right-hand side is our teacher. We want to thank Huawei for providing Model Arts. It's a one-stop AI platform for developers. The machine learning, deep learning, and data pre-processing and interactive intelligent labeling, distributed training, automated model generation features are very helpful for us. We also want to thank Huawei Cloud for providing a one-stop cloud migration platform. It reduces the difficulty of project deployment. Huawei Cloud also has strong computing resources and provides 24/7 resource services. It's been a great help for us. Thank you. You are right on time. You have taken exactly 10 minutes. Now we will come to the Q&A. Please stop sharing your screen. We'll start the countdown. I have a question. With regard to registration, you just show 3 types of images. Why is that? Second, how do you do registration? Based on what? Third, what are the criteria for selecting the ultimate images? I don't really follow. Can you repeat your question? What are you talking about when you say registration? There are 3 types of registration: the original image registration, the smile registration. Okay, I got it. On the left-hand side is the original image. Through registration, there's a lot of original raw data. They have different topologies. So our first step is to make them or turn them into the same topology. But based on what? How do you turn them into the same topology? We have a face template. We have built a template. We want all of the original images to fit the face template. This will facilitate future processing. I think some of your presentation is a bit like dissertation defense. So do you directly take some of the content from your dissertation? Yes. You mentioned that the pain points in the industry of creating digital humans is that it's too costly and it's not fast enough. But how is your solution better? I didn't see that in your presentation. Second, digital humans are needed for some industries. I think you need to come up with an interactive phase or UX so that users can select the industry to create digital humans, or they can enter their habits and user behavior. This way, industries or digital humans that are really suited to them can be recommended. Let me answer the first question. You ask about if our solution can speed up modeling. The traditional solution relies on a lot of human labor. It relies heavily on those who build models manually. It takes 2 to 3 people 1 month to come up with a model. But our solution harnesses artificial intelligence, deep learning, and a high volume of data to automatically generate 3D face models by batch. This reduces our demands for human modeling architects. In addition, our solution is faster. It takes 2 to 3 minutes to generate models. In the traditional solution, it takes half a month or 1 month to render the model, but our solution doesn't need that. That's why it's superior. It's a low-cost and fast solution for 3D face modeling. That's my answer to the first question. I will answer the second. Just now, you said we should allow users to select the industry and generate digital humans for them that are better fit. At this moment, we mainly provide key technologies to generate 3D models. We haven't thought about applications in industries yet. Time is up. Thank you for your answers. You still have a long way to go. I hope you can achieve even greater success with your project down the line. Thank you.
Now let's welcome the next team from South China Normal University. Please unmute yourself and turn on the camera. Okay, let me share my screen. You have 10 minutes for presentation and 5 minutes for Q&A. Now let's start the countdown. Distinguished judges, good morning. I'm from South China Normal University. The title of our work is Huawei Cloud-Based AIoT Multimodal Intelligent Ward System. According to statistics, in China, there are a lot of patients and there is a heavy burden for the medical system. There is a large number of handicapped people and there is policy support. So we investigated the scenario of ward. We find whether patients or their family have real demand. In the ward scenario, sometimes because patients cannot move around freely, they are not likely to be very happy. So we made some investigations and we found brain-computer interface and speech recognition technology may come in to help them. That's why we have developed this AIoT multimodal intelligent ward system. We mainly use Huawei Cloud IoT, Light OS, and Harmony OS. We have applied technologies such as brain control technology and smart operation. This is an overview of the design. We have mainly considered three roles: doctors and nurses, patients, and their family. We use different devices and use digital media to enable interaction. That mainly involves BCI, emotion detection, and so on. So it involves 4 devices on 4 endpoints, including patients, doctors, management, family, wristband, headband, control board, and speech recognition devices. It has 8 features so that doctors can exercise control. And the key is to enable the interaction between the patients and the system. So from the bottom up, we have developed this interaction board. And for the lower end terminal, we use Light OS because it enables real-time processing. It is very stable and consumes little power. So we choose Huawei Light OS. And we also need cloud services. So we applied cloud-based technologies of Huawei Cloud to enable the storage of data and data transmission. For the family member end, they can use this application to monitor the health status of the patient. We have used Harmony OS to enable detection of patients' mental well-being and issue some early warnings. So in this project, we mainly focused on the BCI system. We use non-invasive devices to ensure safety. And we use different algorithms and different templates to work out a control instruction. And this instruction is transmitted through IoT devices to enable interaction between the patient and the system. We have developed some algorithms for interaction and identification. So our project mainly aims to solve problems in traditional warding systems. For example, sometimes there is a heavy burden for the doctors and nurses, and the patients also have heavy mental burden. We want to enable medical services that can help patients live with higher dignity. So we must consider different aspects, roles, modes, and use different technologies. We hope our system can be used to help the handicapped people. Since 2019, the project has been around for 3 years. And in terms of the identification algorithms, functions, as well as devices, we have made innovations. We also filed for patents. And since 2019, we have also been promoting our project because our project is more than R&D, but also for bringing real benefits to people. So we also made a lot of effort in promoting our project. For example, we have attended exhibitions in different places. And from 2020 to 2022, we have worked with different hospitals to help them improve the existing ward system. It has been applied in many scenarios. For example, it is used to help the recovery of patients and also to increase their happiness. And for the handicapped people, our system can also provide them with a simple way of interaction with the system. We have also attended competitions. Now, in terms of prospects, our purpose or our value proposition is only when the technology is translated into real products will it be meaningful. So we will continuously make innovations to build up a good brand. Innovation is very important. We need to make continuous innovations. And in terms of software and hardware, apart from chipsets, we self-developed all these other components. We have achieved technical independence, and we also promoted some positive outcomes to a wider range. Okay, that's all from me. Thank you. Now I'd like to show you the UI of the patient's end and the doctor's end. First, for the patient's end, we have provided the BCI to enable interaction between the patient and the system. So we use the brain waves to control the movement of the mouse to click particular functions. And for the doctor's end, there are all kinds of indicators such as one's health status, and as well as hospital guidance enabled by AI. We are now developing more features, and we have demos already. For example, this hospital guidance powered by AI. Okay, that's all from me. Now the floor is open. I'm looking forward to your questions. Thank you for your detailed presentation, including the application of your device or your system. Now, please end the screen sharing so that we can see your face. Now you have 5 minutes for Q&A. Are you ready? Yes. Okay, now let's start. Okay, I have 2 questions, or 1 question, 1 suggestion. First, how do you obtain the brainwave signal? And just now, you showed us, for example, control of AC, door, and so on. Does it require training for the patients? So that's my question. Okay. Thank you for your question. First, for the brainwave device, as you may have seen, there is a headband. So the patient can wear the headband, and the device can collect the brain waves, electric signals, and the signals will then be transmitted to data processing modules. We apply algorithms to identify the features of the certain scenario and to enable control by the patient. And as for training, yes, they need to undergo training. You know, there are a lot of things in common in terms of the brainwaves between different people, but there is also a difference between different people. So we also provide this calibration function. For example, we use data of one's eye motion to do some analysis to achieve the control by the patient. Now, within 10 seconds, they can receive the training within 10 seconds and can control the system. So just now you said you use multiple ways to monitor the patient's status, but for different patients and different statuses, you may need to monitor different indicators. So is there an interface where you can set up the parameters, for example, what kind of indicators you need to monitor and what is the early warning strategy? Okay, for the time being, now we only have two modules. One is for the brainwave and the other for emotion detection. And some patients, they may have problems with their awareness, and the status is relatively stable. In this case, our system is functioning well. And for other kinds of patients, we are now considering fusing different technologies, such as by using sensors and use jitters to inhibit some low-frequency noises so as to make our system available and usable by these kind of patients, because we do have identified that different patients should be dealt with differently. That's why we need to make corresponding improvements. So slide 18 or 19, you have got an award from China, right? Yes. What is the competition exactly? Well, it is a national ICT competition, a little bit like this global final. So compared with the award you received in 2021, so since 2021, is there any new progress? Well, for the progress, we, the band used to, you have to wear the band around the head, but we want to make it smaller, and you can, maybe in the future you can just plug the device into the ear. So we are making improvements. But in terms of feasibility analysis, it takes 5 months. So we are still in the phase of R&D. And apart from that, in terms of assistive medicine service, we are also working on that to improve the accuracy rate. Okay, thank you so much for your wonderful presentation. Just now you said only when a technology has been turned into a real product will R&D really bear fruits.
Next, we will have with us the team from Xiamen University. Thank you for your presentation. You can just log off. Contestants from Xiamen University, please unmute and turn on the camera. Please share your screen. We can see you and we can see the screen. You can get started. You have 10 minutes for presentation and 5 minutes to answer questions. You can get started. Hello to all judges. My name is Chen Zhuo. I'm from Xiamen University. Our team is called TCI. I will show you a programming platform for primary and secondary students. My talk covers 4 parts. First, I will talk about the project background. China attaches increasing importance to maker education. If you look at the domestic market, there is a big gap in maker education, and it's very challenging for primary and secondary school students to learn to make something for themselves and learn coding. Xiamen has held maker competitions for 4 years running, and our coach is also sitting on the steering committee of this competition. This is the background. And when our team members participate in a tech summer camp for primary and secondary school students, we have encountered some challenges. For example, we cannot get the teaching resources we need, and online education is quite tricky. You can take a look at the photo. we are offering maker courses. We want to use Huawei's Harmony OS development board to create an automated programming platform for primary and secondary school students. This is where the project comes in. Next, we will talk about our design ideas. First, we want to develop a building block programming platform that adapts to Huawei's Harmony OS development board. We have selected HI 3681. Students can perform graphical programming on this platform, and then we will do the development board burning. Then we implement functions such as car control and IoT interaction. We have also designed teaching slides for this platform. Here are more design ideas. This is a building block programming platform. This is the code, GPIO code. With this code, users will be able to click on the yellow light. This piece of code is for control. These are simplified building blocks, so you can combine different building blocks instead of writing code. This is easy to use, and the code is fully visible and the logic is clear. This is the implementation logic. In terms of compiling, we have 3 ways of doing it, including Windows and Linux cross-compilation, Windows compilation, and Linux compilation. But eventually, we decide to implement a graphical programming platform based on the Windows system. These are the key technical points. Platform deployment, code downloading, one-click compilation and burning, and integration multiple code features in the development board, one-click cross-compilation, and more. First, we need to build a platform. We do secondary development based on Google Blockly and use JavaScript. This is our code in the platform. Then with one-click compilation and burning, we leverage Huawei LightOS Studio. We use CMD to call other compilation features and establish a connection with the development board. As for feature code, porting and integration, we encapsulate multiple .c files so that they can be called directly, and the code can be generated. Here are the innovations in this solution. This graphical programming platform supports custom design, and we have also developed some teaching slides and courses. This is very easy for primary and secondary school students to use. And we have turned modules into teaching experiment boxes. And all the compilation platforms and development boards are developed in China. The solution combines hardware and software and is highly scalable. That's all from me. The image is frozen. We cannot hear you anymore. Let's wait a bit. Contestants from Xiamen University, your image is frozen. Would you mind stop sharing and then share it again? You can also try turning off the camera. Please wait a bit. We'll try to connect again. I can hear you, but there's no video. Now it's working. Sorry for the internet connectivity issue. I will show you my code. This is our programming platform. I only need to drag and drop to combine the modules. So you can see the lights can change from red to yellow to green. Then I click download, save code, click compile. Compilation starts now. The implementation logic is also displayed. And there's the OLED, light control, car control, timer, event control, and more. Compilation is completed now. And the code is burnt onto the development board. Our platform is highly scalable. We only need to add more building blocks and more code to support more features. This can attract the interest of primary and secondary school students, and this can support a wider range of scenarios. The platform is quite flexible. The car can turn left or turn right. Now I will show you the details of our development board. You can see the lights are flickering on the development board. I will go back to the slides now. Back to the slides. This is our web programming platform. You can see the editing section and the code section. This is a demo of controlling the traffic lights. I already showed you earlier. I will skip this slide. This is the experiment box. This is the platform for controlling vehicles. These are our teaching slides. Next, I'll talk about promoting the application. Xiamen has held maker competitions for primary and secondary school students in several years running. We have worked with several primary and secondary school students to roll out pilots. These are photos where we provide building block programming services. And we have received a lot of feedback from teachers and students, and we are keeping refining our project. And our solutions are recommended in the maker competition. That's all from me. Thank you. You can stop sharing the slides so you can see the judges in the room. You have 5 minutes to answer the questions now. The countdown starts. I have a question. Just now you talked about car control, etc. So these are the functions you have designed in advance. But is it possible to add more functions, and how will you do that? We encapsulate code and call the modules to add functions. We add more functions to the underlying files to exhibit more features. So who will do the job? Will the developers add the modules to the files, or will the teachers or students in the schools you are working with doing the job? Usually we do this. But if you need to develop other functions such as environment monitoring or control of traffic lights, you still have a lot of work to do, right? Yes. These functions can be supported by hardware, right? Yes. Is it possible to configure third-party boards to expand the functions so that there will be more functions on this programming platform? Yes, we are thinking about that. We are thinking about adding more peripherals to expand the functions. In vehicle control, we also use another board, and we call the external hardware resources. You already show us some pictures of the classroom where you teach primary school students to program. Do they have any advice for you? What is the user experience like for them? Well, our solution is far from perfect. Some functions are still missing. We mainly help them code some complex functions. We have developed a script so that they only need to click to move our code to their project. That's all for the Q&A. Thank you for your presentation and for answering the questions. You still have 1 minute 47 seconds left. Do you have anything to add? If no, that's all for Xiamen University team. Thanks for a wonderful presentation. Judges, you can start scoring them.
Now we'll have the last team for the morning session, the team from East China Normal University. So the team from East China Normal University, you can unmute yourself and turn on your camera. Can you hear us? Yes. Please share your screen. Can you see it? Yes. You have 10 minutes for presentation and 5 minutes for Q&A. Are you ready? Yes. Okay, let's go. The countdown starts. Hello everyone. Today I'm going to talk to you about the Harmony OS-based HRV mental well-being analysis system. Our team is from East China Normal University. We work on both ICT technology and psychology. In China, there are about 95 million people suffering from depression. 1/4 of college students think they have depression. The Ministry of Education also takes this seriously. So what are the existing ways to assess one's mental well-being? Well, it mainly relies on the self-report inventory. It takes a long time to fill out the questionnaire, and sometimes the students just don't want to fill out this questionnaire. So we wonder if there are better ways. After some research, we decided to use HRV as an indicator to detect one's mental well-being, which means if there is change in the HRV, then we can make predictions about one's likelihood of suffering from depression. So what is HRV exactly? Now, you may be very familiar with ECG. HRV is one indicator derived from the ECG. It depicts the change between in the interval between two heartbeats. It mainly involves the 5 parameters on the slide. There are changes, there are variances between a person suffering from depression and a normal person. The traditional approach to assess one's mental well-being is self-report inventory, but the people may lie about the answers. Another way is to use brainwave to detect one's mental well-being, but it is an invasive surgery. HRV is another indicator we can use to analyze one's mental well-being, and it is non-invasive. In South Korea, they have been using this indicator to screen out the people suffering from depression. Now, traditionally, we use the multi-conductor device, but it is not convenient and very costly. That's why we decided to use this new wristband. But for wristband, it uses photoelectric detection, and it may lose a lot of signals. So these are the two existing approaches. That's why we want to find a better way to monitor one's mental well-being. We hope that it can be highly convenient, easy to use, so we contacted with students in the computer science department. So our system consists of 5 parts. First, collection of bioelectric signals. Then we upload data to the cloud. We generate HRV reports. We analyze one's mental well-being, and then we display the results on the front end. One highlight of our product is that it is highly convenient. It only takes 3 electrode patches. You just put them on your left arm, and the right side of stomach. Then you can detect your heart rate. And we also use HRV-based technology to analyze one's mental well-being. There is no existing solution in this regard. So this is the architecture. It comprises several parts. We use HI3861 chipset as a processor. We also adopted the Harmony OS, which features distributed application. Then we collect the bioelectric signals. We also developed the second version of hardware. We converged different components, and the size is 4 × 6 centimeters. It is highly compact. We collect data like ADC sampling rate, and then we apply medium filtering. Because different people have different characteristics of heart rates, that's why we have applied first-order difference and weighted mean value methods. We use 64 RVs as a group. Then we calculate the frequency allocation. On the left-hand side, you can see the parameters we have used. This is the flow chart. There are 2 tasks and 1 software timer. This is the flow chart. On the Huawei ECS server, there is an MQTT server and an external server. On the right-hand side, this is the cloud architecture. After it has established connections with Huawei ECS, we update the real-time heart rate status to the front end. Now this is about cloud application. It has 3 parts. First, this is the UI of data display. In the report section, you can view all the parameters. And last, the analysis page, you can get the results of one's mental well-being. Now let me talk a little bit about our applications. First, we have done the sample tests. We divided people into two groups, one suffering from depression, other healthy group, and the accuracy rate is about 90%. In terms of business model for B2B, it can be applied in schools, enterprises, and psychological service centers. For the service and oriented enterprises, they can use our technology to build up a responsible corporate image. And for the psychological service center, they can use our technology to provide professional services. And for the B2C business, it can help people suffering from depression as well as healthy people to do some self-checks. And psychiatrists can also use our application. Now, let me introduce to you a special case that's about COVID-19. According to reports, due to the pandemic, there is a 25% increase of people suffering from depression. In this scenario, people are eager to know about their mental well-being. If there are any problems, they can adopt interventions early on. But it is often very difficult for them to go to a hospital, and if they use some methods collected from online to do some self-evaluation, the results may not be accurate and professional. And people also may need to know about their mood swings. That's where our HRV detection system can come in. First, it is very user-friendly. You don't need assistance from a professional, and you can do the analysis just at home. You can get the real-time report result, so it can satisfy the demand of self-evaluating one's mental well-being. And especially due to the pandemic, you cannot go outside freely. You can use our technology to evaluate your mental status by yourselves. That's all from me. Now I'd like to show you a demo.
可以看到吗？
可以的。
使用时呢，首先要将3块电极贴在身上。
Okay, first you need to put the 3 patches on yourself. On the right-hand side, you can see this module. After you put the patches on yourself, then it connected to the Huawei server, and then the data will be uploaded to the cloud. This is the front end. First, here is a bar chart, and you can see the HRV, and you can also see the heart rate. And by clicking the module, you can see the detailed parameters. So with the 64 HRV, you can get parameters like time frequency, related parameters. And here you can get the result of one's mental well-being with outputs from the 5 indicators. And we will flag up the abnormal indicators. And then you may get the results, for example, slightly optimistic or slightly depressed. And after you remove the patches, you can see the detection stops. And if you then put on the patches, the detection resumes. And if the power is off, again the LED light will be on. So that's all for the demo. That's all from us. Now I'm open to your questions. Okay, thank you. Right on time. Actually, personally, I also want to try your device. Now let's move on to the Q&A part. Any questions from our judges? I have one question. Just now you talked about your test results. For the 2 groups of people, the accuracy rate is 90% and 92% respectively. How do you get the figure? Okay, let me get back to that slide. So there are two groups. One group is people suffering from depression. They have already been diagnosed with depression. So in this case, if our device can generate the correct result, then we think the answer is right. And the same approach applies to the healthy group. If the result is slightly optimistic, then we also consider it correct. So there is a standard answer to evaluate one's mental well-being, right? Yes. So do you have a product? For example, also the external design of the product, which means your product may be launched to the market in the future. Yes, in terms of the appearance, the external design, we are working on that, but we haven't done. That's why I haven't displayed that. Okay, back to the question. In Shanghai, you know, the pandemic was really serious. So many people just can't go outside, couldn't go outside. So did you use your device to do the self-assessment? Well, you know, at that time, my classmates cannot go out of the campus, so we let them use our devices. If the result is, for example, slightly depressed, then we can give them some guidance and suggestions. For example, they can consult more psychiatrists, and I think the result is pretty good. So could you give us some figures? For example, how many people have used the device and what is the accuracy rate? Well, in terms of the accuracy rate, because at that time we were all in quarantine, so we cannot make sure whether they have really been diagnosed of the depression. But dozens of students used our device. Okay, I don't know if you have done this experiment. For example, there is a questionnaire, people can answer questions. So have you ever did an experiment, for example, when people are filling out these questionnaires and they can also use your device to evaluate the accuracy rate? Answer, yes, we have done that. And the results from the self-report inventory as well as the results generated by our device are presented to the user. A question. So there are two results, slightly optimistic, slightly depressed. And if there are two anomalies, then you consider it is slightly depressed. But I think you can have indicators of finer granularity. And for the people who have got the result of slightly depressed, maybe you can ask them to do this test again. If for a certain period of time the result is the same, maybe at the back end side, you can just connect this data with the school system, because I think these people really deserve more care in terms of their mental well-being. That's my suggestion. Okay, thank you. Okay, thank you so much for the team from East China Normal University. Thank you for your wonderful presentation. That's all for the morning session of the innovation competition. Thank you again for your preparation and presentation, as well as the time for our judges, as well as the online audience who have stayed tuned with us. Now, our afternoon session will start in 2 p.m. Beijing time. So please stay tuned. That's all for the morning session. I'll see you in the afternoon.
The vision of the competition is to promote innovation and entrepreneurship transformation in colleges and universities. It aims to cultivate ICT talent, strengthen global scientific and technological exchange and development. Also, offer equal access to quality education to help bridge digital divide and achieve digital inclusion globally.
The participants of Huawei ICT competition are students in Huawei ICT academies and higher education institutions around the world. 150,000 students have signed up for